All right, today's lesson is on powers and exponents. We've worked a little bit with it with area and volume, but I just want to make sure that you are familiar with it. So if I look at this, I would say this as 5 to the second power, okay? The 5 is called my base number. This 2 up here is called my exponent. All this simply means is my base number, this is my base, this is my exponent. The exponent tells me how many of those base numbers I'm multiplying. So 5 to the second power actually means 5 times 5. It means that I'm multiplying my base, 2 of them, okay? So the answer to that would actually be 25, okay? If I had 2 to the 5th power, my base is 2, so that's what I'm multiplying. So that would just be 2 times 2 times 2 times 2 times 2. It just means that it's my base and I'm multiplying it 2 different times. Now, when you do this, be very careful because that doesn't mean I'm counting by 2s. It means I'm multiplying by 2. So that means this is 2 times 2 is 4, times 2 is 8, times 2 would be 16, times 2 would be 32. So 2 to the 5th power is 32. It is not 10. It does not mean 2 times 5, okay? So easy way for us to make sure that we look at it is we're going to look at it in exponential notation or exponent notation and expanded form. So exponential notation just means that it has an exponent in it. It has an exponent, okay? So if I look at this one, I would call that 3 to the 4th power, okay? Expanded form simply means I want you to expand it. It kind of helps you. What exactly does that mean? So that would actually mean 3 times 3 times 3 times 3, because 3 is my base. The exponent up here tells me how many of those bases I'm multiplying, okay? And then standard form would just be the answer, okay? So my answer here would be 81. So you can grab a calculator to figure that out. You can just go 3 times 3 times 3 times 3, okay? Or you could look at it this way. 3 times 3 is 9, and this 3 times 3 is 9. So 9 times 9 would be 81, okay? All right, so let's look at these. So a couple of these, if we're going to compare them, if we want to know which one like is the greater value, okay, so you have to kind of work them out, okay, you have to work them out. So 5 to the 2nd power actually means 5 times 5, so that would be 25. But 4 to the 3rd power means 4 times 4 times 4. So 4 times 4 is 16 times 4, even if you didn't know that answer, you would know that it has to be more than 25, okay? So 16 times 4 actually is 64. So this would be the greater number, okay? Let's look at this one. 2 to the 4th power or 5 times 2. Well, I can easily do 5 times 2 is 10. And I know that 2 to the 4th power is 2 times 2 times 2 times 2. Well, gosh, 2 times 2 is 4. Times 2 is 8. Oh, times 2 is 16. So that's the greater number. Okay. So you can keep going through these. If you look at this one, 3 to the 5th power or 2 to the 6th, or sorry, that's 6 to the 2nd power, 6 to the 2nd power. Well, 6 to the 2nd is 6 times 6 is 36. I know that one, but let's look at this one. So 3 times 3 times 3 times 3. Whoo! I've got a lot of base numbers I'm multiplying here. So 3 times 3 is 9. Times 3 is 27. And then times 3, I already know I'm going to get past 36. So that one has to be my bigger number. Okay. One of the other things to look at, if I have the same base number, let's say I'm just looking at 5 to the 2nd power or 9 to the 2nd power. Okay. I was supposed to say or. If I have the same, raising it to the same exponent, okay, the same power, whichever I have my base is going to be the higher number. Okay. All right, so kind of look at those. So if you have these that you have to compare, you might have to just work out both sides so that you can figure out which answer is the greater number, okay? All right, so when we deal with exponents, there's some that have special names, and we've used these with area and volume. So certain ones you've heard me say a squared number. You've heard me say a squared number. So I'm going to look at my picture here. So if I look at this, these are all perfect squares. They form squares. Okay. So if I look at this, this is a 2 by 2 square. So a 2 by 2 square that has 4 on the inside. So 4 is considered a perfect square. 3 by 3, that would be 9. So 9 is considered a perfect square. A 4 by 4 square, there's 16. So that's considered a perfect square. 5 by 5, that is 25. So that's considered a perfect square. And 6 by 6 is 36. And you just keep going because this would be 2 to the second power. That equals 4. 3 to the second power is 9. 4 to the second, okay? Or 4 squared. You can say it 4 squared. You've heard me say this. 5 to the second or 5 squared. 6 to the second or 6 squared, okay? So like I could say 9 squared, and you should know that that is 9 times 9, which would be 81. So 81 is a squared number, okay? Remember, anytime we're dealing with area, your answer should be squared or to the second power because we're dealing with length and width, okay? The other one we're looking at is cubed numbers, cube numbers. Okay, cubed numbers are, they're looking at three numbers. They're looking at three-dimensional. Okay, so if I look at this one, I've got 3 going this way, I've got 3 going this way, and then I have 3 going up here, the height. So there's 3 dimension there. Okay, so I can't really draw my cubes, but here's a picture. So if you look at this one, this is a 1 by 1 by 1 cube, so that's just 1. So 1 to the third power would equal 1. This is a 2 by 2 by 2 cube. So 2 times 2 times 2, or 2 to the third power, would equal 8. This is a 3 by 3 by 3 cube. So that's 3 to the third, which would give me 27. This is a 4 by 4 by 4. So that's 4 to the third power, or 4 cubed. That gives me 64. This is a 5 by 5 by 5. So that's 5 cubed. That's 125. Okay, so that's why when we deal with volume, your answer is always in cubic units or to the third power because we're looking at length, width, and height. Okay? All right, so let's just summarize really quick. So anytime I'm dealing with squared numbers, my answer, you can say it's like 5 to the second power, okay? Or I can say 5 squared. Okay, squared means it's raised to the second power. Cubed numbers means it is raised to the third power. Okay, so if I had 5 cubed, okay, so remember, 5 cubed means 5 times 5 times 5. 5 squared means 5 times 5. Okay? All right, so if I wanted to find the area of this square, let's say this is a 3, I'm telling you that the length is 3 here, okay? What do we know about a square? We know that a square has all lengths are the exact same. So if I say this is 3, then you should know that this is 3, you should know that this is 3, and you should know that this is 3. So the area of this square would just be 3 times 3, or 3 squared, which equals 9, okay? Now, if I had a cube, oh gosh, let's see if I can draw it. If I have a cube, whoa, look at that beautiful cube, okay? Let's say this is I tell you the length of this cube is 2, okay? So if I were gonna find the volume of this cube, it would be 2 to the third power because that is 2 by 2 by 2. Okay, so that would be 8. All right. All right, so let's see this one. All right, so if a square has a side length of 8, can we easily find the area? Can you easily find the area? Well, if I tell you the side is 8, don't you know that this side is 8? So the area would simply be 8 times 8, which is 64, okay? Or that would be 8 to the second power, or 8 squared, okay? If I tell you that the square has an area of 25, can we easily find the length? So in this case, you want to kind of figure out, well, if I know that the area is 25, that means what times what had to give me that 25. So what number times itself had to give me 25? So that means my square had to have a length of 5 because 5 times 5 gives me 25. Okay, so the length would have to be 5 feet. Okay, that does not have a power or an exponent there because it's just length. Okay. All right, so let's look at the cube. So if we have a cube, the side length is 4, can we find the volume? Well, that just means it is a 4 by 4 by 4. So that's just 4 times 4 times 4. Okay, so that equals 64. Okay, and let's say it was inches, so it should be inches cubed. Okay, what's behind here? Let's see. Oh, there's my cube. Delete. Okay, let's look here. So what about surface area? Ooh, surface area is a little different now. So remember surface area, this is what I need for surface area. So I told you, we know that it's 4. We know that each one of these is 4. Okay, we know that each one of these is 4. So let's just look at one square. Let's focus on one square. So what is the area of this one square here? Length times width, so that would be 16. Okay, so don't I know that all of them would be 16 then? So I could simply add them. Okay, I know that they're all 16. Okay, but I don't want to add that 6 times. So I would just say the area of 1 is 16 times, and then I know there's 1, 2, 3, 4, 5, 6 faces on a cube. So I'd multiply that. 16 times 6. So that's 36, comma 3, 96. Its surface area, again, this is inches, so inches squared. Okay. All right, let's start you off on your decimal slide here then. So a cube has an edge of 11 inches. A cube, okay, so that's three-dimensional. So we're looking at a cube. So we know the cube, let me draw my lovely cube. So we know that it is 11 inches. So volume, remember volume equals length times width times height. So no matter what the length of your cube is, isn't it always going to be volume? Is it going to equal this, whatever the side length is to the third power? Because they're all going to be the exact same. So volume is always going to be the side length to the third power. Okay, and then surface area, remember what we found last time? So the surface area is going to be, the side length to the second power, because that gives me area. That gives me area. I should have done area first. That gives me area, and then times 6, because there's 6 different faces. Okay? All right, so for this one, the volume, that would be 11 times 11 times 11, whatever your answer is. And then surface area is going to be 11 times 11, and then times 6. Okay? All right, why don't you go ahead and get started on your decimals and let me know if you have any questions.